math stream for tutoring and math help. So if you have a math question that you would like to ask, or you have a problem that you would like to see worked out, feel free to post in the chat and I will do my best. In the meantime, I am going to be looking at a graph, a Quartic graph. So a Quartic graph is a fourth degree polynomial, and I'll be using this thing called a rational roots theorem to analyze this graph, but I want to kind of digress, so I'm going to go ahead and get right into it. I hope everyone is well, and yeah, so we'll just pick up where I left off yesterday. I think that I took too long and I didn't finish, and then I kind of didn't have a lot of confidence about what my graph was supposed to look like. I actually got closer than I thought. I plugged it into Desmos after my stream yesterday, and this side of the graph looks almost correct. However, it's a rough sketch, and like you can see, my points aren't even. Maybe one of these days I'll get a pretty grid to lay over my board, and I can graph them more accurately. But I didn't even fill in the table, and that's okay. I'm learning. This learning experience for me, so I'm just going to scrap this function. I picked another function, and yeah, if nobody has any questions about math and that they post, then I'll just practice working on my board and drawing the math out, because that's I feel like that's the skill that I need to develop the most. Okay, so I'm just going to go ahead and erase this. And the fourth degree polynomial has many terms, so it's going to take a little bit of time too. And I apologize for that. It's just, I feel like that. Why rush? I don't know. Why rush? I know we like to have the short method whenever I am looking for a YouTube video on how to do something. I want to find the shortest video possible. But I think that mathematics is something that you just have to take your time, take a deep breath, and be committed, be able to commit the time to it. All right, so let's see. And I'll label this one graphing a Quartic function. However, I don't know how much in this. Might be a two-part. This might be a 2-day because these functions are not pretty, and they do take a lot of effort sometimes to analyze. When I was trying to find a good function to work with, or one that sometimes it's hard to pick them, but I was trying to find one. I intentionally found one that wasn't factored just so I would have the experience factoring it, because it did give me one that was already factored and it was tempting. All right, here we go. So we have f of x, and a Quartic function is a fourth degree polynomial. So you have your leading term is a fourth degree. So we got 2x squared minus 17x cubed plus 46x squared minus 43x plus 12. Okay. And just double check the terms and make sure. Okay, 2x to the fourth, 17x cubed, 46x squared, 43x, and plus 12. All right. So like always, the critical values of the graph are going to be the same. So if you, we'll go ahead and put our table in here. And I am going to try my best to fill this table in. I realized yesterday, and I wasn't able to watch the entire live stream yesterday, but I have been trying to discipline myself to go back and watch them. And because it's like, just in case somebody watches my video, I want to know what they're watching, how bad it is. And I figure it's pretty bad in the beginning because, yeah, I don't plan on, jumping into something new and expecting to be all spectacular at it. But I do try to leave some room for growth. And hopefully I grow. Anyway, so I was thinking about the pre-calculus, and it has been a few years. And I remember trying to find the roots. It's kind of like a game where you try real roots, and you hope that there are real roots, but they're not guaranteed. And it's like, well, am I just trying any random number? There are a lot of theorems around solving these higher order polynomials, and one of them I remember was called the rational roots theorem. And rational roots theorem essentially is saying, like, basically there's a way to tell like the possible roots of a function. So basically you put, I think it's P and Q, and then it's all possible fractions of P over Q, I think. Hang on. So P over Q. So it has to be, so it says P is a factor of, let's see, P is a factor of the leading, and Q is a factor of, and then so it's all possibilities of these. So you have P equals 2, well, P equals 2, and Q equals 12. So it's like all possibilities of the factors of 2 and 12. So 2 goes into itself. So you have, 1. So the factors of 2 are 1 and 2. The factors of 12 are 1, 2, 3, 4, and 6. And 12, a number would be a factor of itself. And then you put all the fractions P over Q now. So you have 2 over 12. Which reduces down to 1/6. And then you have all possibilities of these fractions. So you already have 2. 2 over 2 is 1. So you have a possibility of 2/3. 2/4 is 1/2, and then 2/6 is 1/3. Do we already have 1/3 on here? And 1/6, which we already listed. And then it's plus or minus all these values. Plus or minus, plus or minus. Minus, there we go. So let me see if I found them all. So we've got 1, 2, 3, 4, 6, 12. Well, it's been a while, but I still found them. 1/2, and it says 3 over 2. 1/2 is 3 over 2. 3 over 2 is here, so I flipped them. And then it's saying not 1/6 and not 1/3, so it's just these two. Anyway, so the rational roots theorem is very helpful if you know it and you apply it right. So maybe I got them mixed up. Let me look it up again. See what it says. And this AI is really handy. It says P over Q 12 and 2. So it's 12 over. All right, so it's P over Q. So you put Q over P. All right. Anyway, so it's been a while and I'm remembering this too. So it's all right. And again, the goal is not to be perfect. It's just to be effective. So if I look perfect, then I'm not doing anybody any favors, because if I'm being a good representative of math, that you have to understand that we're all human beings and we're going to make mistakes and it's a moving target. So just allow yourself to not be perfect and you're fine. So, okay. Anyway, so we have all of these possibilities, and what you're going to do is you'll just I start with the easiest one, to be honest. We could also start with the fractions if you wanted to. This one, let's see. If we were going to just do it by hand on one of them, it's like brute force, but you can use the calculator as well. And so just looking at 12, so it's 12 divided by 2. I should have known that. 12 divided by 2 is 6. So that's the first one that I want to try. So I'll try just the positive 6. Actually, let's try 1 just to practice. 1 is a much better because it's easiest to evaluate. Plus and minus 1. So 2 times 1 to the 4th minus 17 times 1 to the 3rd plus 46 times 1 squared minus 43 times 1 and plus 12. And that's close enough. All right. So 1 to the 4th is 1. So you just have 2. All these terms that contain 1 are just going to be 1. So it's 2 minus 17 plus 46 minus 43 plus 12. And then what I'll do is just the easiest thing to do. 46 minus 43 is 3. Positive 3. So you have 2 minus 17 plus 3 plus 12. And then that's 14, 15, 16, 7. Oh, 0. I got lucky. So I didn't even look it up because I wanted to practice, but trying to force myself to remember as much of the math and not to be lazy is hard. So, but I got lucky. 12 plus 5 is 17, and then you have a minus 17. So as soon as you find a 0, if you plug in your root into your function and you evaluate and you get a 0, that means that it is a clean factor of that polynomial. And you use synthetic division, which I'm probably going to start today. So far I've been dividing those polynomials by hand, long division style, but there's a short method, synthetic division, that I want to practice. So we'll start with that 0 and break this polynomial down. So what I want to do is, since I have one root, I want to go ahead and list all these possibilities and erase all this. So let me write them down here. So I've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. Is that really all of them? And then plus or minus 12. And then we had some fractions, 3/2, and plus or minus 1/2. Okay. And then we so far found 1 is a real 0. All right. So I can have room. And again, what we'll do is we'll start this today, and then yeah, I don't this might be a 2-day graph, but that's okay. We'll start building it, just work through it, and get to practice all sorts of things. So rational roots theorem, it's pretty handy. There's some other theorems that I don't remember right now that I'm going to have to slowly just let my mind. So far, it's been pretty good where I'm just slowly remembering things. I haven't ran into any blocks yet, so hopefully I'll remember more of the math as I go, which is one of the goals with this project. So, all right, I have a 0 at +1, and so when y is 0, x is 1, and I know that 1, 0 is on there. And so what I'm going to do is I'm going to use synthetic division to figure out my other polynomial, and then we'll have to do this again. All right, so let's go. All right, we have the method, you're actually using the 0, so I have 1. And I'm going to divide it into this entire polynomial here. So I'm just listing the coefficients only. And making sure that there's no gaps. So it has to be in standard form, and making sure that it's in descending order from least or from greatest to least. And then you're making sure that there's no gaps, that there is an X term. So 4, 3, 2, 1, and 0. So there has to be an X term for every single term in between 0 and 4. So if there's not, then you would plug in a 0. All right, and then the method begins by drawing a line and bringing this first value down, 2. And what you're doing is you're making a synthetic division here. So 2 by making a multiplication. So you're multiplying this number by this number and putting it here. So it becomes, so it's 2 times 1 is 2. And then you should, if you do it correctly, spoiler alert, you're going to get a 0 here at the end, because again, we're not trying to figure out if it's a 0. We already used the function to determine it was a 0. What we're trying to do is we're trying to get that leftover polynomial so we can continue to factor it, to find all of the factors, because there's probably many of them. We have at least 4 crossings potentially. All right, so, or I mean, at the most we have 4. At the least, it's probably at least 2. Most of these 4th degree polynomials have y-axis symmetry. They're even functions, and their end behavior is, if it's a positive function, you're going out to infinity through the first two quadrants. So understanding and just over the time you see the patterns, and then also there's theory behind it. And I don't know why I got into the graphs so much in my math classes, but I did. I always enjoyed graphing. So anyway, I got off on a tangent again. Negative 17 plus 2 is negative 15. And then negative 15 times 1 is negative 15. And then 46 from 15 is 31, positive 31, I believe. And I should double check because I don't want to make a mistake. But I'll find out in a minute if I made a mistake, because I should get 0. And if I don't, then I know. So 1 times 31 is 31. And then 43 from 31 is, what is that, 10? 12. That's 12. So 3 minus 1 is 2, and 1 minus 4 is negative 12. And then negative 12 looks like we did it good. We did a good job. All right. So 12 minus 12 is 0. Perfect. But more importantly, what we're doing is we're finding that leftover polynomial, because we have this 0 at x equals 1. And remember, if we want to solve this and we want it to set it equal to 0, then what we're going to do is we're going to do a reverse of the one-step equation and just subtract 1 from both sides. And what we're doing is we're creating a factor. X minus 1 equals 0. And so this factor times whatever this factor is going to equal this. So what you're doing is you're just taking the, so x divided by x to the 4th is x third. So this becomes 2x to the 3rd minus 15x squared plus 31x minus 12. So this is just telling you what that polynomial is. So this times x minus 1 is equivalent to that. They're the same function. So continuing the math, we have all of these potential zeros to check. Let's try one of the fractions. And it's good practice too, seeing the context of this math. So let's see, I didn't mean to write x there. So I want to figure out which one of these fractions to try. I kind of want to try the 1/2, but seems like it wouldn't be too hard to calculate. It's good practice to get good at order operations and the algebra. So we've got, I'm going to try to write this from this direction so you can see it. So 2x to the 4th minus 17. Oh, wait a second. I'm not going to do that one. I can do either polynomial. This one is easier, so I'm going to do that one. Minus 15x squared plus 31 times 1/2 minus 12. All right, make sure I have it all in there correctly. And then we're just going to simplify. So 1/2 cubed, that's 2 times 1, 2 times 2 times 2 is 8. minus, so let's see, 1/2 squared minus 15 times 1/4. And then 31 halves. That's, I'm just going to write that as a fraction, 31 halves, and then minus 12. And we can reduce this one down a little bit. 2 goes into 8 4, so that is 1/4. And then we have minus 15 fourths. I'm going to go ahead and turn this one into a proper fraction so we can add it real quick. That's going to become 62 fourths. And then 12 times 4 is 48. So that's going to be 48 fourths. And then that's easier because I can just add them. So what do we got? 1, 15, 62, and 48. So that's positive 63 and negative, let's see, 52. What was that? 63. Oh, did we get lucky again? No. Wait a second. 63 minus, is that really minus 63? I'm not going to believe it until I see it. So I'm going to go ahead and double check in the calculator. 63. It could be my brain wanting it to be, and so I'm trying to force it to happen. All right. So 1 minus 15 plus 62 times 3. Yep, 0. Okay, 0 divided by 4 is just 0. Because you can divide a 0 by a number, but you can't divide a number by 0. So we got lucky again somehow. And we've got this 1/2 here. 1/2 is 0. So we can actually see if I'm going to plot this. I know that I have my y-intercept at positive 12. So let's see. I can probably make 12 up there. We got that one, and then we've got x equals 1. 1, 2, 3, 4, 5, 6, 7. All right, that. And then I've got a 0 at positive 1. And positive 1/2. So we've got 2 zeros in there. So how do we do that? We're going to have the scale off by 1, right? So we'll just make that 1/2. 1/2, 1, 3 halves, 2, 5 halves, 3, and then what is that? 7 halves. Okay. And then that'll be negative. All right, so we've got 1/2 and 1. That way we can have clean points on the graph. All right. So now that 1/2 is a 0, we're going to use 1/2 to synthetically divide. So fractions work the same way, and there's no better way to get good at fractions than to see how useful they are and like how necessary they are. Like, you're gonna deal with fractions at some point in your life, so you might as well get good at them, practice them. So what I'm going to do is I'm going to use this 1/2 0, and I'm going to plug into, I'm going to use synthetic division in that polynomial because I'm trying to split it up. Okay. And then I didn't even think about trying to use calculus to try to find the local maximum and minimums. So that might be something that we do tomorrow, because I'm already 30 minutes in. All right. So let's synthetically divide 1/2 into this polynomial here. Let's see, we've got 2, -15, 31, and -12. And so the process, we'll get some good practice. So we've got 2, bring that first digit down, and 2 times 1/2 is 1. And again, spoiler alert, when we do it, if we do all of the calculations correctly, then we should get 0 here. So, all right, -15 plus 1 is -14. And then so far so good because everything's been even and it's been evenly divisible. -14 divided by 2 or times 1/2 is -7. And then let's see, 30 minus 7, that's 24. Positive 24, good. And then that works out. So 24 divided by 2 is 12. And -12 plus 12 is 0. All right, good. So we have this polynomial. And remember, when you divide, you have a cube, and so you have x to the third, and you divide it by x, you're getting x to the squared. So x squared. So when you're doing this synthetic division, it's just a shorthand of long division. So in essence, you're still long dividing, you're just doing a shortcut, just dealing with the coefficients. So we are still doing the same process. It's still happening. So what this term is going to be is a square term now. And it's nice because I'm back in quadratics land, and that is my comfortability. Like, I'm very comfortable with quadratics. I used to be, I guess I'll say. My persona is comfortable with quadratics. My actual physical person is out of practice and very lazy and needs to get back into shape. But we'll just see what happens. All right, so we're going to write this polynomial. We have 2x squared minus 14x plus 24. And this is a natural factor of the polynomial. We also have 2 other factors. We have x minus 1, and then multiplication is it's associative, so order does not matter. So I can go ahead and put this other factor in here as soon as I figure it out. What I have here with this 1/2 is I have x equals 1/2. So what I have to do is, and it's a little, this is a 2-step equation now, because now I am multiplying both sides by 2. 2x equal 1. And now I'm subtracting by 1 both sides. So this is going to be 2x minus 1 equals 0. And as soon as you have this solved for 0, this is your factor. So this is the actual factor. 2x minus 1. And this is equivalent to this polynomial, this one. And all we're doing is we're further splitting it up. And so I found both of those factors. I'm going to use this polynomial now. Okay. This 2x squared 2x squared minus 14x plus 24. And what I could do is I could let's see here. I could see if I could factor it. So if I divide off of 2, I'd have to remultiply that too, but that would be x squared minus 7x plus 12. And then let's see if I can get the factors real quick. If not, we'll use the quadratics, the quadratic formula, or completing the square. I can try that again. I used to love completing the square, and you'd be surprised, like how fast you forget some, or me anyways. I was real fast to forget that stuff. All right, so 12, let's see, I can make 7 pretty easy with 4 and 3. 4 and 3. So this will just be 2 times all of that. And then I want it positive, so that's easy enough because I can add those. 4, negative 3 is negative 7, and then when you multiply 2 negatives, you make it positive. 4 times 3 is 12. I think we did it. All right, so here is the factors, the other factors. And so let's write them all out. We've got x equals, let's see. So you take these individual factors and you set them equal to 0. The 2, see the 2, when you go to solve this thing, the 2 is going to go away, but it's still in here. There's still a 2 in there. I don't need to put it there yet. We'll go ahead and write it all out. Okay. I'll write it right underneath here. And I'll erase this one. How long we're into it, yeah. Okay, so we might go ahead and just finish. We'll write this out. We've got it factored. And we could kind of try to list them in order if you wanted to. X minus 1 times, so we've got x minus 1, 2x minus 1. We got that one. And then we've got x minus 4. We'll do x minus 3, x minus 4. And remember, order does not matter when you're multiplying. It does not change the outcome. So as long as you have them all in there, then you're good. So I have this one, this one, this one, this one, and this one. I think I have them all. Goodness gracious. All right, so we can go ahead and put the table in here. So I've got I have to actually find the zeros here. So that was taking x minus 4 equals 0 and x minus 3 equals 0. Just adding 4 to both sides, solving this one-step equation, you're going to get x equals 4. So over here at x equals 4. And so we'll put that 4. Hopefully that's the last value we try. And then x equals 3 is also a 0. So we'll have some more points in here to check. So we'll have 3, 2, 1, 1/2. doesn't look like that this graph, oh yeah, it crosses the y-axis, it has to. So at right here, it's crossing. All right, so anyway, all right, we're getting closer, and I'll go ahead and just get this table down. So I'm going to list these points in order. So far we have, I'm going to do 0. See, because we have that 12. That's the easiest point for me to find is the y-intercept sometimes because it's when x is 0. So whenever you have a very large polynomial, all your x terms are going to 0, so you can just kind of focus on that last term, the constant term. And it's nice, it works out. All right, so we have this one, and then we'll do listing in from least to greatest, that 1/2. And then we had 1, 2, 3, 4. And what I'll probably do is we can stop there. I'll list the zeros in here. So we have 1/2, comma, 0, 1, comma, 0, 3, comma, 0, and 4, comma, 0. I'm going to evaluate the function at 2 and 5. And then we'll go ahead and stop after that. And what I'll do is I'll just pick this up and we'll start off tomorrow first thing, and I'll use the calculus. We'll do the derivatives. We'll find the first and second derivative and help us to find the other critical points on the graph and the if there's any local maxes or mins. All right, so let's go ahead and what are we going to do? Oh yeah, so we'll go ahead and plug in, find a couple more values, and then that'll be good enough for me. We can stop. All right, so we have this factored form of the polynomial. And we're just going to plug in and evaluate it. Add a couple more points to get a couple more points on for our table here. And so we've got, let's see, f of 2. So we're going to evaluate it 2 more times, practicing our algebra or order of operations. So 2 times 2 to the 4th minus 17 times 2. And bring it out of the way so you can see what I'm writing. Cubed plus 46 times 2 squared minus 43 times 2 plus 12. You get them all in there. All right. And then I got to remember what 2 raised to the 4th power is. The base 2 numbers. That's 16 times 2 is 32. 2 cubed is 8. 8 times 17. 8 times 7 is 56. And 8 times 10 is, all right. 136. Sometimes my brain will just do the math, but I always want to double check anyway. 46 times 4. 184. Especially when I'm in the middle of online live, I want to make sure, because when I watch it later, if I find a mistake, I'll be mortified. 43 times 2, that's 86 plus 12. So what we got here? Just gonna put this in. 3684. I'm getting 6. I put 2 as 6. So we've got 2, 6. Two, 6 is on the graph. And just one more good. And then we can draw a rough sketch, and then we'll find the maxes, and we will work with the same function tomorrow because I think it's a good one. Mark this day on the calendar. I actually picked a good function. All right, I had help though. Okay, let's see. F of 5 now. Let's just do one more. Not too bad because most of us can count pretty quickly by 5s and 2s, so those aren't brutal numbers. 2 times 5 to the 4th minus 17. Oh, you know what? Let's go ahead and practice the other one real quick instead of doing that one. So since I have this factor here, I should be able to just find it here this way. 2 times 5 minus 1 times 2 times 5 minus 1 times 5 minus 3 times, I'm getting in a hurry, writing too fast, times 5 minus 4. And I can simplify it this way. So that's 2 times 5 minus 1 is 4. 2 times 5 is 10, minus 1 is 9. And then 5 minus 3 is 2. And 5 minus 4 is 1. So that's 8 times 9 times 2. So 8 times 9 is 72 times 2. Was that 144? All right, so 2x to the 4th. I'm just going to double check real quick. Minus 17x cubed plus 46x squared minus 43x plus 12. And I'm going to check 5. Okay. Right, 2x to the 4th minus 17x cubed plus 46x squared minus 43x plus 12. All right, I'm just getting 72. So I don't think that I think 2 is going to go away. Honestly. It's there. I don't understand. All right, let me just think about it. All right, it's saying it's 72. So it could be syntax, it could be me. But regardless, that is off the chart. So by the time it gets out to 5, it's already at 72. So we're taking 5 off. And then I'll have to think about this thing. All right, that might be a good place to stop. What we can do, though, is possibly, I just want to guess. Because I know that it's going that direction, and it's already at 5. It's that was a positive 72. So I think it's doing this number at 4. So we have this type of thing going on. All right. I just don't know because we can find these minimum values here. We can find them using calculus tomorrow. So, yeah. Quartic functions, fourth degree polynomials. Just continuing the discussion. So what we'll do is I will figure out whether 2 is going to stay or go. And if it goes, we'll take it off tomorrow. And if it stays, we'll leave it on there. All right. So we better go ahead and stop there. And good solid 50 minutes in. And again, I just want to say thank you so much for watching my videos. And yeah, if you want to come hang out with me and do some math Monday through Friday on YouTube, I'll be here in this capacity from 6 p.m. to 7 p.m. Central Time. And I look forward to being here tomorrow. So I will see you then. Bye.